For the null hypothesis, H0, we are going to let the population mean be equal to 37. As for the alternative hypothesis, according to the question, the managing director believes that the mean age of the employees is now less than 37. So less than 37. A sample is carried out for 80 people, so n is equal to 80. And the sample mean, which is an unknown, I'm going to let it be k. This is what I'm going to try to solve for. And the population variance is given to us by the question is 140. With this, let us try to write down the test statistics. For the test statistics, x bar will follow a normal distribution with a mean of 37 and a variance of 140 divided by 80. And this is possible because of the central limit theorem, n is large. If I were to standardize this, that means z, which will be equal to x bar minus 37 divided by the square root of 140 over 80 will follow a normal distribution of 0, 1. And according to the question, H0 is going to be rejected. So to reject H0, we are going to make sure that the p-value is going to be less than the level of significance that is given to us by the question as 5%, so less than 0.05. What we are looking at here is a left tail test, which means that for 0.05, it is going to be on the left hand side here. This is the critical region. It has an area of 0.05, and since the rejection is happening, that means k must be residing on the left hand side of this value, and this portion here represents the p-value. So p-value will be probability when x bar is less than k. This is less than 0.05. If I were to press this into my calculator, I'll get a range of values for k. K is going to be less than 34.824, which means the set of values that x bar can take will be from 0, since x bar is the mean age, it cannot be less than 0. And since we are going to round off to a value that is smaller, I'm going to let this be less than or equal to 34.8 to 3 significant figure.